Hello, I'm Pinaki Nath Chaudhary and I'll be presenting our work Unsupervised Document Binarization Network via Adversarial Game UDBNET. The work was done in collaboration with Amandeep Kumar from Techno Main Solvik, Sector 5, Kolkata, Shubhajit Ghosh from Institute of Engineering and Management, Kolkata, myself, Pinaki Nath Chaudhary from Indian Statistical Institute, Kolkata, Parthapratim Roy from Indian Institute of Technology, Roorkee, and Uma Podopal from Indian Statistical Institute, Kolkata. We separate our presentation into 10 sections. First, we talk about the challenges in document image binarization, followed by the supervised methods for binarization. Next, we talk about unsupervised binarization method by Bhunia et al., which we use as our baseline. We next describes the limitations of Bhunia et al., followed by our motivation. This leads to the overview of our solution, which consists of two components. First, adversarial texture augmentation network, and the second, the unsupervised document binarization network. We present some result and finally conclude. The challenges in document image binarization include but not limited to faint characters, bleed through background, dark patches, non-uniform variation of intensity. To solve these problems, supervised binarization method uses ground truth binarized image along with their degraded version. But this is not ideal, specifically for the case of historical documents where we do not have access to ground truth binarized images. To solve this problem, Bhunia et al. Came up with the unsupervised binarization method that removes the requirement of having ground truth binarized images. But Bhunia et al. Has some key limitations. The first being texture augmentation network TANet is completely unaware about the content at which it is conditioned on. Therefore, it cannot verify the content of the generated noisy image remain consistent or not. Second, there exists no performance quantifier that validates the performance of binarization or BINET on real degraded noisy images. Third, the binarization network has a dataset bias towards generated noisy images, which is not dealt with by any kind of formulation or other techniques. Our motivation is that these limitations occur due to the straightforward implementation of two-player GAN objective that tries to model two different uncorrelated conditional distributions. We address this limitation by introducing an adversarial min-max game in the domain of unsupervised document image binarization. We first represent a schematic framework, the schematic representation of our solution, where the yellow highlighted region depict our contribution over Bhunia et al. Our solution basically consists of an adversarial texture augmentation network or ATNet and an unsupervised document binarization network or UDBNet, which involves in a three-player GAN objective. The third player is a joint discriminator that tries to couple the ATNet with the UDBNet. We briefly describe our ATNet, which includes a generator T that takes an input clean image and generates its noisy version, a discriminator DT that tries to distinguish or discriminate between the generated noisy and ground truth noisy images, and the joint discriminator JD that tries to discriminate whether a pair of data consisting of a noisy and a clean image comes from the joint distribution of real noisy and its generated clean, or ground or real clean and its generated noisy. This leads to our adversarial loss depicted in equation 1. Next, we see in equation 2, the adversarial loss is coupled with LS, which is the style loss, and LC, the content loss, similar to that of our baseline Bhunia et al. We next describe our unsupervised document binarization network or UDBNet. UDBNet consists of a generator F that takes input a degraded image and generates its clean version. Discriminator DF tries to determine between the generated clean and the ground truth clean images. The joint discriminator JD tries to distinguish whether a pair of noisy and clean image comes from a joint distribution of real clean and is generated noisy, or real noisy and is generated clean. That leads to our equation 3, which represents adversarial loss for our UDBNet. Equation 4 gives the overall objective for UDBNet. We next present some qualitative results where we see that our generated binarized results are much more better than that of Bhunia et al. And is very close to the ground truth clean images. We also do an experiment on the historical documents and we see that ours is again giving much qualitatively better result than Bhunia et al. We present some quantitative metrics on 4 metrics: F measure, FPS, PSNR, DRD, and we propose some alternative baseline. First is a domain confusion loss represented by the UDBNET CL, and the second is gradient reversal layer, UDBNET GRL. We see that our proposed method performs better than these two baselines. And we also compared our method with a lot of state-of-the-art techniques, where we see on DIBCO 2011 dataset ours perform consistently better than all the other comparative methods. We also perform our experiment on DIBCO 2016, where we see that ours perform better. To conclude, we propose ATNet and UDBNet to solve the problem, and our experiments on DIBCO dataset shows superior performance compared to existing methods. Hope you have some questions. Please check out our code. Thank you.